This is a thermochemistry problem where we use enthalpy as a conversion factor. What is the enthalpy change when 25.5 grams of NH3 are reacted with 54.4 grams of O2? And we're given the equation 4NH3 plus 5O2 yields 4NO plus 6H2O. And we're given the delta H is negative 908 kilojoules per mole of reaction. So that means that this delta H is a conversion factor for each and every species of the reaction. There's negative 908 kilojoules for every 4 moles of NH3, for every 5 moles of O2, for every 4 moles of NO, and for every 6 moles of H2O. All right, so I strongly encourage you to pause the video at this point and try to do the problem on your own, and then check back and see how well you did. All right, so we're given that we have 25.5 grams of NH3 and 54.4 grams of O2. So we're given the amounts of both of our reactants. So this means that we have a limiting reactant problem. We have to see which one of these reactants gets used up. And that will be the value that we'll use to figure out the change in the enthalpy. So we need to change our grams to moles. So for ammonia, our molar mass, 17.03 grams per mole. And then for oxygen, our molar mass, 32.00 grams per mole. And then we can do our ice table. So we have 25.5 divided by 17.03. So we get 1.50 moles of NH3, and 54.4 divided by 32 equals 1.70 moles of O2. So now we'll do our limiting reactant trick. We take the moles divided by the coefficient to see whichever one is smaller. So 1.5 divided by 4 is equal to 0.375, and 1.7 divided by 5 is equal to 0.34. The smaller value gives us our limiting reactant. So oxygen is our limiting reactant, so therefore we use up all 1.70 moles of the O2, leaving us with 0 at the end of the reaction. Now, I don't need to fill in the rest of the ice table because the limiting reactant information gives me everything I need to figure out the delta H. Remember that our limiting reactant controls everything. It controls how much of the other reactant or reactants get used up, and it controls the amount of products that get formed. So now I know how much heat is released for every 5 moles of O2. I need to figure out how much heat is released for 1.70 moles of O2. So X kilojoules equals 1.70 moles of O2 times negative 908 kilojoules for every 5 moles of O2. So just do that calculation. 1.7 times negative 908 divided by 5 equals. So our answer is negative 309 kilojoules.